Hi, I'm Curtis Brown. I'm here from Texas Instruments, and I'm here with my good friend John Urschel. And John's got some really great stuff for us in this video 2 of our Smart Space videos for geometry. We're exploring the different types of rigid transformations. So in the first video, we talked about what a rigid transformation was. And in this video, we're going to be talking about the different types of rigid transformations and kind of how they interrelate. So John, can you take it away?
Yeah, absolutely. Okay, so in this session, the main thing we want to do is formally introduce sort of 3 basic types of rigid transformations. And if you were with us for the last session, you know that we've already talked about these things a little bit informally, things about translations, rotations, reflections, but we really want to dig into each of these different types and look at their sort of unique properties. We're going to look at an example of each of these, and we're going to try to learn how to recognize each type of these transformations. And first, I want to talk about these transformations from just from a more intuitive perspective. I want you to think about these transformations as things you can do with a transparent piece of paper with some shape drawn on it. And imagine like what the different things you could do with that piece of paper are without bending it or folding it. So I actually have an overhead, which if you were with me last time, you know, so I'll share that with you guys. And let's just like think about some of the different things we can do. So here's the overhead. First, we got to draw something. So first I'll just go over the X and Y axis so we can see what happens to that. And next, we have to draw a shape. Curtis, what's your favorite animal? What do you?
My favorite animal?
Yeah.
Well, let's do an easy one. Dog.
I like a dog. I got news for you.
Like
no matter what animal you told me, they'll pretty much all look the same. This is my drawing skills. So here's my dog. He's got some legs. He's got a little tail. That's his tail. And here's his head. See, isn't that
John? You draw your dogs facing to the left. And
yeah.
I pretty much always draw my dogs facing to the right.
I see.
Are you left-handed?
Ambidextrous. So,
Okay.
Yeah, but I'm doing right for this one because it's sort of easier to.
Yeah.
But, okay, we have a nice little dog, but here I can even give him a little smile.
Give him one eyeball. All right.
Smile. There we go. So that's our happy little dog. And so the question is, what different things could we do to this dog using this transparent piece of paper we have here without like bending this thing, folding this thing? What can we do? Well, we start with the dog here. One thing you can always do is you can slide a piece of paper. Right? So if we're just sliding it like this, that's just translation. You can sort of like, you can put your finger down somewhere and you can spin it around.
So that would be a rotation.
So that's like a rotation.
Mm-hmm.
And pretty much anything you do without picking up this piece of paper, like anywhere I move this thing, you can always think of this as like a rotation and a translation together. So for instance, like I could put this piece of paper, I could put this transparency anywhere I want. Like I put it right here.
Right.
I can show you that I can get back to where we started just by putting my finger down somewhere, say here, spinning it, and now just shifting it down and to the right.
I think that's brilliant, John. I think it's super important that students kind of grab a hold of the fact that really what you've shown us just now is that any transformation, any of those rigid transformations can be a translation and a rotation, with the exception of what you're about to show me right now, I imagine.
Yes. So to start, we started pretty simple. We said we can't pick the piece of paper up. It's got to stay down. But the thing is, we know from last time that if you pick a piece of paper up and you flip it over, it's the same shape. it's just reflected. And so this also preserves length. And so we can see that it's still the same shape, lengths are still preserved, and we can just flip it. And we can flip the piece of paper in different ways. Flip it like this, flip it like that, flip it like this. The shape is sort of always still the same. And again, you can actually show that anywhere you put this dog, I can always get it back to this original position by rotating this piece of paper, flipping it, or just shifting it somewhere. And so these are the three sort of fundamental things you can do with this piece of paper, you should imagine. And that means that these are actually sort of the three basic rigid transformations. And you can get any rigid transformation out from these three things. Like for instance, Curtis, like you can tell me where you want me to put this piece of paper. Like I could put it like, you want me to start here maybe? Like I could start anywhere.
Sure, I think that's really good, except rotate them a little bit more so the entire dog's in the fourth quadrant.
Like this.
Yeah, there we go.
Okay, the dog's hanging out there. So the first thing I'm going to do is I'm just going to, here, I'll put them right here to make it easier. First thing I'm going to do is I'm just going to rotate this dog. So let me just spin my piece of paper. Okay. Next thing I'm going to do, oh, I took a little bit of
that's all right.
X and Y axis off. That's okay. Next thing I'm going to do is I'm just going to flip this piece of paper over.
Okay.
And
right
let's say
or across the original y-axis?
I'll flip it here so that the y-axis stays where it was before.
Okay, good.
Okay, so I flipped it. The y-axis is still where it was before. You can only see like the tiny little head of the dog. But I've got news for you. Now when I shift it, hold on, got a little stuck. Now when I shift it, oh, the dog's coming back.
You just altered the fabric of the universe.
And he's right where he was before. Okay?
That's perfect. That's perfect. So you showed, so in that example that you just did, you showed all three rigid transformations. You did, first you did a rotation. Mm-hmm. Then you did a reflection.
Yes.
Third, you did a translation. Mm-hmm. So that's the three basic rigid transformations that we have available to us. You can
exactly, like these are the things you can do. You can slide the paper, you can spin it, or you can flip it over. And you can sort of see intuitively that any like rigid transformation you give me, you can put this dog wherever you want. I'm just going to do these three things and I'm going to bring it back home.
That's awesome. Yeah. John, I think that's the first time I've seen an actual overhead projector in, I don't know, 20 years.
Oh, listen, I'm with you. It's been forever for me as well. But I think, you know, for the concepts of sort of rigid transformations, I think it's really helpful to have this hands-on example.
I love that. I absolutely love it.
All right. So now that we sort of intuitively understand what these three things are and why sort of these three specific types of transformations are important, let's try to think about these things a little bit more rigorously and a little bit sort of more mathematically. So let's start with translation. So a translation, which is, these are all terms we've been using sort of colloquially, but now let's define them mathematically. So a translation is just a rigid transformation where all points move the same distance and in the same direction. And so one key point about a translation is you can always write a translation, like a translation applied to some XY coordinates, XY. You can always write it as those XY coordinates plus some point U in the plane.
Okay.
So for instance, like here's an example that we have up on the slide. Let's say T of XY goes to X plus 5 and Y minus 4. You can see that every single point, all you're doing is you're just adding the point 5, negative 4 to it.
So John, I've got a question for you then.
Yeah.
If you put us back on your clear transparency there, I've got to guess. I think the origin of your new plane is going to also be at that point. X is positive 5, Y is negative 4.
First of all, that's a great guess because 0, 0 plus the point 5, negative 4 equals 5, negative 4. So we know that our transformation, first of all, the X and Y axes always stay sort of parallel to where they were before. And we know that
Right.
the origin is just going to go to 5 and -4. And that
Now,
is
all of those points for the dog were also mapped 5 units to the right and 4 units down. That's awesome.
exactly. Yeah.
That's awesome. So everybody got moved, including that origin.
Exactly. And all the same distance and in the same direction.
Cool.
Okay. So that's
Cool.
translation.
All right.
Rotation. Oh, hold on a second. We're missing a little bit of the bottom of the slide. There we go. So a rotation, this is just a rigid transformation that just turns all the points around some fixed location, which we'll just call the center of rotation.
Okay.
Okay.
Yep.
And so the rotation, it does have an explicit formula. I understand it looks a little messy for rotating by a specific angle. So it's often better to think about these rotations geometrically, which is really what we'll do. But I do want to let you know there does exist a formula for this.
For sure.
And so an example of a rotation that we can look at is, let's rotate something 90 degrees counterclockwise around the point -2, -3.
Okay.
And so you can see we have this triangle that we're starting out with. And once we transform it, all we're doing is we're just rotating it about this point -2, -3. And I got news for you. If you couldn't guess it by now, we're about to rotate this dog by 90 degrees counterclockwise as well.
Nice. Are you going to rotate it around the point -2,
We are. So let's take a look at -2, -3. This point is right here.
Okay.
Okay. So all I'm going to do is I'm just going to keep this point reserved, and I'm just going to move this 90 degrees.
That's awesome.
There we go.
Perfect.
And that's our rotation. This is just illustrating what this rotation T does. We rotated 90 degrees counterclockwise, and we kept the point 2, 3 exactly where it was before.
Okay.
Okay, so this is rotation. Now we got one more left. Let's talk reflection. So a reflection is just a rigid transformation that flips all the points across some fixed line. And we're going to call this line the line of reflection. So this one is actually much more complicated even than rotations to write sort of a closed form formula for it algebraically. So I really think it's best we just think about this one geometrically without writing a general formula for it. And an example could be reflecting points across the line y equals x minus 1. And so what I have here is a triangle and the line y equals x minus 1. And we've just flipped this triangle over. This is a reflection. And again, if you can't guess yet, what are we about to do? Curtis, you have any idea what we might do?
Transparency.
Right now? Let's look at the transparency. So first of all, let's get rid of this point 2, -3. We don't need it anymore. And now why don't we draw this line y equals x minus 1. Okay? So let me just do a little dotted line. We're going right to the dog. He's okay, don't worry. Okay, so we have this point y equals x minus 1. And now what we're going to do is we're going to reflect across this line. So that means when we flip our piece of paper over, this line is going to stay where it was before.
Right.
So what I'm going to do.
So it's still going to go through the point -1, 0, right?
Exactly. So this line is exactly where it was before. And we see that the dog has been reflected across this line.
That's awesome.
Yeah. So this is reflection.
Okay. So I think take those ones now. John, I'm a little bit afraid, but I think you're about to ask me some quiz questions.
I'm about to ask everyone some quiz questions. So now that we've gone through the three different types of transformations, rigid transformations, I want to know, can you guys recognize them? Take a second at home. I've got three rigid transformations for you here. And I want you to either at home, well, preferably using sort of geometry for each one of these, plot a few points and try to tell me what type of rigid transformation is each of these. Okay, so just take a second, try this at home, pause the video, and come back when you've thought about this for a second.
Okay, John, I think I'm ready to try the first one.
All right.
I'm ready to try the first one. So let me, I'm going to go ahead and I'll share my screen here.
Okay.
So let's see, that very first transformation, I'm going to go ahead and just look and see what it does.
Mm-hmm.
So that first transformation you had, we're going to take all these points here. We're going to map them, all the x values to x minus 4 and all the y values to y plus 2, right?
Mm-hmm. And x minus 4, when you subtract 4 in the x coordinate, this means 4 units to the left. And when you add 2 in the y coordinate, this is 2 units up, right?
2 units up. And that looks like what I've done. 4 units to the left, 2 units up. Mm-hmm. So I believe that that is in fact a transformation. And so what I'm going to do, I'm going to first...
A translation.
A transformation that is a translation.
Yes.
So I'm going to put a vector down here. I'm just going to drop in a line that is 4 units to the left and 2 units up. And I'm going to say, hey, we're going to take this entire plane and we're going to do this. And I'm going to put a little polygon on top of this.
Okay.
Put a polygon right on top of that, right on top of this guy here. So let's do it. There's a polygon right here. Okay. And we're going to take that polygon and we're going to do that translation that you have given me to do. So I'm going to take this polygon. Mm-hmm. And I'm going to do that translation and look at, lo and behold, it maps it directly on top of this one here. So the first one was a translation.
Right. And we know it's a translation because all the points moved the same distance and in the same direction.
That's perfect. John, can you tell us the problem again? I forgot what problem number 2 was.
Okay. So let's take a look at problem number 2. Problem number 2 is looking at the rigid transformation that takes xy to negative y, negative x. Curtis, you think you know how to figure this one out?
I think I can figure this one out. I think I can do it.
All right, you ready?
I'm going to share my screen here in just a second.
Okay. All
right, so I'm ready to, no, I'm not. Ready to share my screen.
All right, let's see it.
So, all right, so looking at screen number 2, let's plop up the next transformation that you gave me. So okay. In transformation number 2, we're going to take negative y, negative x as our possibilities there, right? Mm-hmm. So we have this shape translated all the way down here. So there's 2 things that I notice about this particular one before I start even trying to guess at what we're doing here. I know this, the pointy end, the longer pointy end here, mm-hmm. Is kind of mapped here to this longer pointy end. And I can't think of, like, if I just take this guy and I spin it around, mm-hmm. It looks like if I just tried to rotate it about the origin, that isn't going to work. I'm not going to get there that way.
Right. It's like it's going the opposite way somehow.
It's going to be on the opposite side. So I don't think there's a rotation that will get me there.
Okay.
Right? That was my first thought, was it's a rotation, but it's not.
No, it's good to check.
See that. So the second thing that I'm going to do is I noted that what you've given me is negative y, negative x. And so the x and y were flipped. That's kind of an indicator to me that maybe we've got a reflection. Mm-hmm. I'm going to try doing a reflection on this guy. So first thing I'm going to do, I'm going to go ahead, I'm going to unhide my polygon there. So I have a polygon, and then I'm going to unhide this line
Okay.
right here, okay? Because I think if I take negative y, negative x, that's kind of like saying that I'm going to take this shape and reflect it across the line where y is equal to the opposite of x, right? So I'm going to take all of the opposite of x's and map them over here. And that also means that all of my x's are going to be mapped to the opposite of the y's that they were. And I think that's going to get me pretty close to what I have here. So let's try that.
Yeah, let's see what it does.
All right. So here we go. We're going to take transformation. We're going to grab reflection. I'm going to say, I'm going to take that polygon and I'm going to map it to a reflection across this line, y equals negative x. And sure enough, I end up with that polygon landing right on top of this set of points that you gave me for that one. So number 2 is a reflection. And in fact, it's a reflection across y equals negative x.
Okay, perfect. That's good.
All right.
So far,
John,
so
you want to
good.
show us the third one?
Yeah, okay. So now let's look at transformation number 3. This sends x to negative y and y to x. Curtis, you think you've got this one figured out?
I think I've got that one figured out. It's going to take me a second to get ready here.
All right, just let me know when you're ready to go.
I will let you know. Okay, so here we go. I'm going to share my screen again.
Okay.
Get that going here. All right. So I'm going to take off this old one that we had here. So I'm going to get, so this is going to be transformation number 3, right? So we don't want transformation 2 anymore. We want transformation number 3. All right, so I'm going to show that one. Ignore these points down here for a moment. All right, so I'm going to look at transformation number 3. And I see here that it looks like this long pointy end is kind of pretty much in the same location. If I look at this particular one, right?
Like so it's oriented the same
sort
way.
of that same orientation. So I'm thinking that it looks like this time I can actually do a rotation. So I'm going to take this geometry here. I'm going to go ahead and put that shape back on top of this one because I want to make sure that we have a shape to move, right? So I'm going to put this guy back on top.
Okay.
So now let's take this guy and we're going to rotate him about the origin. And the reason I think it's about the origin, look at the point that we have here. This is at the point 2, 1, and this is at the point -1, +2. So I'm thinking that it's about the origin that we're going to actually do this rotation. So I'm going to try this guy. I'm going to say I'm going to take that polygon and rotate it about this origin right here. Okay, so I'm going to type that in. And then it looks to me like you've rotated it about 90 degrees, right? So I'm going to type in that 90 degrees and just see. And sure enough,
oh, wow. Okay.
90 degrees is where we end up with. So I've actually taken this point and I've rotated it here to this, this set of points and rotated it here to this set of points by 90 degrees. So
90 degrees about
so the third one was a rotation.
Okay, good. All right, I think we've got all 3 figured out. Curtis, I think you get 100%.
I get 100%. That's awesome.
Yeah, the first one was just a translation 2 units up, 4 units to the left. The second one, you were spot on. It was a reflection across the line y equals -x. And the last one was just a 90-degree counterclockwise rotation about the origin.
John, do you want to share those solutions with us on the screen? Let me stop sharing my screen here.
Yeah.
All right.
All right.
So 2 units up.
Yeah, so the
left.
first one was just a translation 2 units up, 4 units to the left. The second one was a reflection across the line y equals -x. And that last one was a 90-degree counterclockwise rotation about the origin.
That's awesome. That's awesome.
All right. And so
well, John,
now,
what are we going to do next time?
Exactly. So let's start talking about next time. We're going to try to combine these different types of rigid transformations to try to make other different types. So trying to I showed you a little bit with the dog, how we can combine these things. but these sort of fun exercises I was doing with the dog here, you're going to get to do yourself next time. And one good
Awesome.
question to ask is, can we make any rigid transformation by using only these three? I mean, sort of spoiler, we can. I think we've really shown this by using the dog, but we're gonna really dig into this more next time. And so
That's awesome.
I look forward to
Something
seeing
for us
you
to
guys
think
then.
about.
Yeah, exactly.
All right. And that was a whole lot of fun. Sure enjoying this and recording these and getting these videos made for some students. So really excited to see what you have for us in the next video. So I guess we'll see you next time.
All right, see you next time.